Hi, Stuart here with another video today on API Design Considerations, Practical Guide. So here's my checklist. I'm not going to get into code in this video. I'm going to get into the ideas that are present in all really good APIs that I've used and even some I myself have made. And for the ones that I've made where I failed to appreciate some of these things, I then paid for it by having very grumpy API consumers. So I thought I would try to bottle this up into one place and then refer to other videos I've done or other videos out on YouTube that have discussed certain aspects of these. But I thought it would be good to have a checklist video that sort of very quickly summarizes the things that are important. So we're going to talk about each of these topics. We're going to talk about embracing DDD. We're going to talk about the tension between your API layer and the storage tier. We're going to talk about living solid. We're going to talk about the wire, the big O's, being evergreen, and semantic versioning. So let's start with embracing DDD. Here's a nice example I pulled from the Microsoft Architecture Microservices domain model. You can go find it on this link. You can just go search for it. It's very easy to find. It comes up very high in the search results. But the point of this slide is it's really, really hard to make a good API that stands the test of time if your API isn't part of a context model or a bounded context, as they'd call it in DDD. That is to say, for example, that we have an accounts domain and we need an API for it so we can program against it. And we want to make an API that serves that domain well. And in order to do that, we have to understand what the bounds of what the accounts API should probably do. What CRUD operations are there available on what objects within that domain, and how do we want to expose those objects as DTOs in the boundary of the API? Because as we'll talk about shortly, we don't want to have our APIs dramatically mirror the underlying storage necessarily, because we may want to change or tune that layer independently of the API. So DTOs are important. We also want to think about what valid scenarios there are when we want to have an API that crosses domain boundaries, that's an aggregator API. And the most common reason, kind of the 80% use case for aggregated APIs, is some sort of reporting function where we need to extract data from our overall domain, and that the data that's asked for crosses multiple domains. And it has relationships between the domains expressed in the relations that we're exposing to our data model. So whether we're exposing a graph or a table or a cube or some other shape, that shape and the relationship between the columns or between the values of the nodes in our heterogeneous graph express relationships. So for example, we may want to say something about, well, what is the domain relationship between accounts and drone sharing? Well, drone sharing is this idea that different accounts will be fractionally billed for drones based on their usage or their allocation in this model. But the other 20% is still a legitimate scenario where we need to make changes to data in the underlying model everywhere it occurs, and that an operation has an impact on all of the places in the domain model, or a lot of places in the domain model simultaneously. So suppose our drone is shot down out of the air. It's not enough to call the drone management endpoint to say, well, this drone no longer exists because it's been obliterated. We could have eventing inside the drone management model that would act as a notification bus to the other parts of the domain model. but we may not be able to count on it. We may want to enforce some saga-like process across our entire domain following the destruction of a drone. So if that particular drone was being allocated, if that particular drone was being billed to an account, if that particular drone was being used to ship something, or was in use by a third-party system, we may need to tell the call center that the thing we promised the drone would do is not going to do it anymore because it's been obliterated. And so we may want to have operations exposed as a saga where we not only systematically deal with the fact that our drone doesn't exist, but also deal with the remediation for that. Well, we're going to have to go source whatever the drone was doing. We're going to need a replacement drone. We're going to need our customers to know. There's probably going to be a compensation mechanism in the account subsystem that says, well, either we're going to charge the customer for the drone because they were responsible for its obliteration, or we are going to credit the customer because they counted on us to deliver this thing with the drone or do this task for the drone, and we weren't able to do it, so they deserve a credit back. The only way to really understand that is to understand the domain model that underlies the API. And some APIs, most APIs, are going to be domain specific. And other types of APIs should be domain spanning. And when we look at your API, it should explicitly say that. It should go, here's our domain model. Here are the APIs for different domains. Click away to go read the documentation. And here's the sorts of operations, and they are typically in the form of some sort of RPC call with a context, because we're typically doing some sort of eventing or other transformation in a sequence, right? And it's to handle this specific scenario, so that we make sure that when the context of a single operation, that the underlying system does the appropriate saga to come up with a compensation, like we talked about previously. There's always this tension between the underlying sort of storage agreement of an API and its representation in the persistence tier. One of the ways of managing that is to simply wish it away by having them be one and the same. And those models tend to be very brittle, but they're very fast to build. So if you need to build something really quickly, that is an option. It's just not a very good option that has longevity. The other way to do it is to do contract first development, and that's my personal favorite. I like to look at my domain. I like to say, what are reasonable contracts that define operations and CRUD operations within the domain or even across domains, and then come up with an operational contract and the operational payloads. And one of the things that's important about that is a certain element of consistency in how you implement those. And we'll talk about that when we get to the O's. But the other thing is that you have to be very careful, unless your APIs are built in the same runtime stack as the underlying data model, which does exist, right? But that's not usually the case. Usually I'm in C# and the data's in Mongo, or I'm in C# and the data is in Oracle, or whatever. We have to think about the types that we're going to use in our DTOs and what their bounds are. We need to be very careful about that. And new languages or newer languages that are general purpose, like Python 3, for example, which has been out for quite a while, but as people build APIs on top of Python, they started running into some interesting problems. Python was designed to handle particularly numeric processing at any scale. And one of the design goals of Python 3 was that integers should be kind of infinitely wide. And the same with floating point numbers, right? That we didn't want to be constrained with the integer width of the hardware or the floating point width of the underlying math chipset, which is typically an IEEE definition. We need to understand anytime we have a transition between one set of technology and another, or one representation and another, which is a type of technology transform, what are the potential areas of trouble? And historically, dates have been a big sticking point. Dates and times, and time zones, and UTC, but also numeric data, and even strings, because if the underlying technology model at the persistence tier uses a null terminator, and our API tier uses a declared length model, so that I have a length predecessor and then I have a block of memory in which the text is, encoding is a problem. Most modern programming stacks are very obliging about silently converting from one kind of encoding to another, but it may not end up having the result you are happy about. So up-translating, say from ASCII to UTF-8, is generally pretty harmless. Cross-translation can be a real bummer, though. So just be aware that you have to respect but not necessarily copy, and you must understand your underlying type system to make a decent API. And in the API tier, you should strive for something that is the most compatible with the most things that are in your non-functional requirements. In other words, if I know in advance that this system, and this system, all written in these different technology stacks, all needs to interact with my API, I need to make sure my API speaks the lingua franca, so to speak, of types that are compatible, and that API consumers understand the bounds limitations of some of the types, both syntactically, like how big can this integer be, and semantically, what does it mean to have a count of this thing? I used to make a lot of API libraries, and to some extent I still do. I have a bunch out on NuGet, and the thing about building libraries for the same programming stack that they're going to be used in is you don't have to really worry about types that much. Because if my NuGet is in C#, in .NET, and my programming stack is in .NET, or my programming library is in NPM, written in TypeScript, and I'm going to use it in Node.js, and, in TypeScript, then I'm going to be a pretty happy guy. But the second you introduce a wire into your life gets progressively more difficult. And one of the things that is really apparent when I'm talking to developers who are designing APIs for the very first time, and in many cases, they don't grok the fact that they are making an API, and what does it mean to make an API? An application programming interface. So you point out, A, that thing you just wrote is an API, and B, it's intended to be consumed by people other than yourself. And therefore, there are things you need to know and things you need to share in order to do it properly. And more API calls are happening over the wire. If you're writing a simple RESTive service, right? Web API on ASP.NET, then you really probably ought to understand IPv4, IPv6, TCP/IP, and HTTPS. I mean, really understand how they work and why, to at least an application developer's degree of certainty. If you're designing a protocol that is going to be a binary protocol or demi-binary protocol, AMPQ or whatever, then you need to understand what the pros and cons of that protocol is and what they look like on the wire and how do they interact and what is a good pattern of interaction for that application layer transport and how does that get translated down onto TCP/IP or in some rare cases UDP and then on to IP. It's astounding how many APIs I've seen and reviewed that get under performance pressure, right? They're put up on the wire and all of a sudden people start calling them and depending on them and they crumble because fundamentally the person who designed the API didn't understand the networking stack upon which the API ultimately depended for success, which brings us to the next thing, which is payload size matters. And if you don't understand the underlying protocols, you don't understand where the bending or breaking point is for a particular payload. And so you don't know when you should build in paging or chunking. I saw an API the other day, and it allowed a 3 gigabyte payload in a post over HTTPS. And I went, golly, that's a bad idea. And not unsurprisingly, not only did it have trouble not timing out a lot when there were no network ephemera in the way, but the second we put API gateways and web firewalls and other appliances that you would need in the enterprise, many of them just looked at that payload and went, no. No. And they failed, and their thing got behind, and it was god awful, and there had to be a discussion with InfoSec, and there had to be a discussion with the networking group, and fundamentally those developers took the business requirement that they needed to be able to pass along big, enormous things, and decided that since HTTP and web APIs were the tools in their toolbox, but they fundamentally didn't understand how they worked, that it was all going to be fine, and it all ended in tears. Well, subtle semantics matter, like patch versus post versus put, and what HTTP options are, and, what are the HTTP headers and their uses, and how does that affect the usability of the API, and where do we put what kinds of control flows into our API. And so if you have any kind of wire-oriented API, then you need to look at the wire behavior early and often, and there are lots and lots of tools to do that. These are the 5 things that when I look at APIs, I use to judge an API. I call them the O's because people will describe their APIs to me in a presentation, like an architecture review, and my response is, Oh. You seem to have missed an O there, my friends. So, the big ones are solid, but particularly open-close. The sign that you have a really well-built API is that people keep finding novel ways to use it, which brings me to a corollary, which is if you have an API and you're not monitoring its use, particularly if that API is on the wire, probably less important if it's built into people's, compiled into people's software like a NuGet or an NPM. But you should probably pay attention to how people are using it and or misusing it. And you can find that out based on the feedback about your API. But a sign of a well-crafted API is that it gets highly adopted because it does follow the open for extension, closed for modification rule in solid. As we've spoken of before, big O, the computer science big O, which is for every n bytes, messages, payloads, whatever, what is the performance profile? Big O of n squared, whatever, right? You need to know what the big O of is. And if you don't understand big O, you need to go back and learn big O so that you can look at the call patterns that you're seeing. And you can look at your algorithms in the profiler built into your favorite tooling, mine is Visual Studio, and understand what happens when somebody invokes one of the methods on your API with different payloads. Organize. It makes me crazy when APIs don't have a consistent naming convention. If their case is all over and doesn't match the underlying programming platform. If the documentation is not in any way coupled in version to the code that's being generated, there's really no excuse for that. Every modern programming language on planet Earth has documentation built into its capability, and there are generators to generate documentation. And like, for example, REST APIs, you can use a tool like Swagger for .NET to generate OpenAPI 3, and you can put annotations on your fields, your DTOs, your methods, on collections of methods, and on the API itself that is gorgeous and detailed and documented. And that shows that you have a good organization. And a good organization then results in your API being obvious. Assuming that you started with domain-driven design, and you have developed a common domain language, and you use it throughout the API, and you have documentation because you are organized that expresses that domain, understanding your API should then flow naturally. And then last, obliging. A good API makes it hard to do the wrong thing, easy to do the right thing, and provides detailed, helpful advice when something goes wrong. Error code E75932 is not obliging. API should be evergreen. Now, evergreen is as much a process-oriented thing as it is a design-oriented thing. So the process-oriented part is ship frequent, incremental, compatible, standards compliant APIs and have a bias towards sustained engineering and rapid innovation. Grind those APIs out. There is nothing more frightening than going to see a library or an API and figuring out when the last time somebody updated it, and it was updated 18 months ago or older. And in incredibly rare cases, it's perfect and needs no changes at all, ever. But that never really happened. If you look at the history of an API and you don't see periodic continuous improvement, you gotta wonder whether or not you should trust your part of the business process to that API. From a design point of view, right, it's got to reflect the domain. Why is that part of Evergreen? Because Evergreen is an expression of sustained engineering and not breaking the world. And domain models tend to have good stability if they're well constructed. And so the resulting APIs have continuous incremental improvement, but also good stability because they are based on a solid set of design principles before you wrote a single line of code. And hopefully you did a bunch of architecture there too. There's this myth, and I don't know where it came from, that your APIs have to have this weird purity test. And people look at your APIs, other people, and they go, well, you seem to be mixing CRUD through represent REST and RPC in your API. And I say, that's okay, but make it clear what is something in the style of go do this process and let me know when it's done versus I have a graph and I want to make a set of changes to the graph and propagate them to the underlying state machine. They can coexist in the same API. Should they coexist in the same collection of operations? Probably not, right? PIs are chunked into sets of interfaces, and the sets of interfaces that have CRUD in them and the sets of interfaces that have RPC style things in them should be different. And you should call it out. These things are used to initiate a process. These things are about maintaining and modifying the underlying state graph. And yes, a database is a state graph. And then, not for nothing, but good APIs have item potency, object reference permanency, definitive object paths, alternative object references, sequencing, paging, searching, sorting, etc. And you can go read or watch some API design videos, and I provide some books at the end that you can go read. If you don't know what some of these things are and you're building an API, you should probably stop and go find out what they are because they're important. But these are all part of the two sides of the Evergreen idea. One is the process side and the other is Evergreen in our design. Start with a good, well-organized, obliging implementation and keep doing it. Semantic versioning. So here's the thing. APIs that are used a lot that are, and if they're public APIs, they're trusted, but even within corporate, inside your enterprise infrastructure, good APIs get a lot of use because they're treated like products. And products are treated with maturity. They have the O's, including decent documentation. And they use semantic versioning with discipline so that you don't break people. And I can't tell you how many just dreadful API ships I have seen in my life where, without changing the methods very much, the method contracts, the interfaces, right? The operational and data agreements between the consumer of the API and the producer of the API, and the producer has broken the semantic context of the API. And then horrible things happen on the persistence tier, or horrible things happen operationally because a series of things is executed that is inappropriate. So the power tip on this is, if you must make semantic changes, deprecate the old operations and make some new ones, ideally in a new interface or namespace, whatever you want to call it, and be really clear about why you had to make the change and what the semantic differences are. And express that by using the right major, minor, and patch. So patch is, we fixed it. It's better now. Minor is, we added some stuff, but it doesn't break anything. We added some more functionality. We added some more nuance. Maybe we added some more documentation. Who knows? But we didn't break anything. Major is, we broke stuff. Stop and go read. And it may sound obvious and simple, but it's amazing how many APIs out in the wild heinously violate this rule. And the APIs that people use and trust, even if they don't like the people who made them, the one thing they can say with certainty is they're going to obey the semantic versioning rules. Don't trust APIs that don't. So here's some books worth reading. Thank you for your kind attention.